Hello and welcome. Today I'm here to talk about our project title Investigation on Plasma Spray Coatings of Cement Bypass Dust and Similar Industrial Waste, which is a feasibility study awarded to us from the Circular Economy Hub, which is a coordinating hub for the National Interdisciplinary Circular Economy Research Hub program awarded to the various partners from the EPSRC, the funding national funding body of the UK. So I am Saurabh Goel, and I am also Associate Director of the EPSRC Network Plus in Digitalized Surface Manufacturing. And along with my investigators, namely Dr. Pravad Ranjanpati and Dr. Vish Venkatachalapati, who are executing this project, have also been able to fortunately involve a PhD student, early career investigator, who is currently learning a myriad of things alongside while working on this project, while we aim to deliver the outcomes from this project. So in the next few minutes, I'm going to talk about what this project is about and so far what we have achieved. Um, and as you can see, the project began first of all through collaborative multidisciplinary expertise ranging from civil engineering, materials engineering, and manufacturing, which has helped this ECR group of BAME origins to transcend the waste to wealth paradigm through a low cost, low energy pathway. And it's the first vital step to promote circular economy in the construction sector through the introduction of a key manufacturing method used for surface engineering, namely thermal spray manufacturing. Now, circular economy, when we talk about, it has got its pillars, and recycling is one of the founding pillars of circular economy. And through this project, what we are able to do is to uptake the lost value that goes in the waste, as shown in the diagram here, which is a very nice work carried out by Professor Hopkinson from the University of Exeter. And he has shown through this image in his article, which is cited below, that a lot of construction materials are wasted and goes into landfill, which loses their value. If otherwise we can take this value up here, then we can basically go towards creating value in terms of added value and circular economy introduction through the principles of circular economy, which will inform new designs for construction and deconstruction and add economic wealth and decarbonize the sector. So taking this as a main motivation, we began our thinking in how can we use the cement bypass dust through the thermal spray technology. So in this project, we are aiming to improve the prospects of recycling in the construction sector by utilizing industrial waste, primarily the cement kiln bypass dust, CBD, which can be used potentially for repair of refractory linings and products, including, for example, chimneys and ovens, which are popularly used in foundry and construction and are seldom repaired and rather dumped into the landfill once they have been detected to be faulty. So through this method, we have conducted a feasibility study, and thermal spray, if I talk about, is a method that can take almost any high melting point material powder, including metals and ceramics, feed them through a robot as shown in this diagram with a gas that allows to generate the plasma. And under those conditions uh, of temperatures, any material can easily be partially molten or fully molten and be deposited on a substrate. So here is a video that shows a thermal imaging camera-based monitoring of the thermal spray system, which is a very well used technology in aviation and power generation sector for coating gas turbine blades. So we are trying to come up with this multidisciplinary idea on using one of the technology, have a niche market in one sector, and on the other construction sector we have cement bypass dust potentially usable as a feedstock material. So the project began by making a kind of postulation of the fact that we can enable recycling of cement bypass dust by taking this value added material, which can be fed into the thermal spray system. And we assigned ourselves respective tasks related to manufacturing and spraying and characterization as shown here. And while taking the feedstock to the thermal spray, obviously we will get a certain type of coating, and that coating can well be characterized and studied, which will then let us make a concrete and affirmative stand that yes, this particular material can well be recycled, and therefore we can confidently say that the first step towards circular economy has been taken. So in on course of this learning, we began our journey by first of all listing out the equipments that are shown here, which were used in this project as part of the characterization. So some of the equipments, for example, included the scanning electron microsystem from Carl Gia's company, which has an integrated energy dispersive spectroscopy, which is extremely vital for us to fully characterize the chemistry of the powder as well as that of the coating before and after thermal spraying to understand what has basically happened to the material itself while it has been undertaken through extreme conditions of plasma temperatures. On the right hand side, what you see here is an X-ray diffraction system from a company called Bruker, which is a vital tool for crystallography understanding of the material, quite analogous to the EDS studies, but XRD being more fundamental in terms of the X-ray um, uh, that are used to characterize the material is a vital instrument again to study the powder and that of the coating. So we basically begin by collecting the raw material, that is the cement bypass dust here, which is shown here. Now, for thermal spray to be effective, what we need to first of all do is to characterize and also to make sure that the powder is properly homogenized and filtered and sieved so that it will have homogeneity while it is going through the hose and the nozzle subsequently of the thermal spray gun. So what we have shown here is a sample of the bypass dust that we have collected and gathered from the source, which was then subsequently sieved and to prepare a homogeneous powder of a uniform size of 63 microns approximately. After this powder was homogenized and sieved, we have taken it to the material characterization instrument such as X-ray diffraction. And that X-ray diffraction revealed that the cement bypass dust, that raw material that we obtained, was primarily consisting of calcium carbonate and silicon dioxide, as shown here through the labels. So the primary composition of the cement bypass dust was seen to be calcite. So it became easier for us to understand what type of gas would be required to decompose this calcite rich compound through during the plasma spray and what sort of processing parameters will be desirable. Now, when we talk about thermal spray, what we intend to do is obviously, first of all, grid blast the substrate so that any oxides can be removed from the substrate. A artificial periodic surface roughness may be introduced in this process because this allows and enables improved mechanical interlocking of the coating to the substrate. So what is shown here is the grids that are used for doing bead blasting. And this is the raw substrate. After it has been grid blasted, it has achieved some artificial roughness, and it is now ready to receive the coating. In order to perform the coating, we then take this substrate, the grid blasted sample, to the coating chamber, which is where the magic happens. So through this plasma spray gun, our aim is to feed the powder over here with the powder feeder unit. And this robot can be programmed with the right selection of the gas and the gas feeder unit on the control unit, which then allows us to spray this particular coating from the gun. And you then receive a coating on the sample, which could be a certain micron thickness. And after the coating has been deposited, you can cut the sample to further mount it in the epoxy for doing further microscopy and further characterization. So that was done here. So after we have deposited the coating, we then performed the characterization, and these are very early stage results. We are still analyzing them, but in the hope of at least discussing through this particular communication video, I hope that we can have a thinking on what do we expect from such kind of studies. So after we have performed the coating, what we found out from X-ray diffraction was the material has now become predominantly rich with calcium oxide rather than calcium carbonate. So this is one of the new learning and understanding on what has happened to the material before and after the spraying has been done. We aim to further gather the data on this particular front, but this is a very early stage result. And after we have done our complete analysis, we aim to publish this data for the open benefit by the other users across the world. And finally, we also started to perform the scanning electron microscopy studies to understand the morphology and the thickness of coating. So one can see the differences between uh, the coating thickness, which is shown here to be about 163 micron, the type of pores and the cracks, etc., that one can expect to see in a thermal spray coating, which is an atmospheric deposition process. It does not include vacuum or anything. So obviously the splat that forms along each strike can have some sort of ununiformity, and those can well be studied through the tools like scanning electron microscope, which are shown here. So overall, what we aimed to achieve was achieved indeed. What we can see here, that raw sample was sent blasted, and the coating was subsequently deposited, which is clearly shown here. And through this study, we aim to enable recycling of the cement bypass dust. So on that note, we are still continuing this study further. And as the results start to come out in more intensity, we aim to generate scientific publication out of it. And on that note, I'm happy to further answer any question you may have through my email or to further collaborate if any avenues for collaboration exist using these facilities. So thank you very much for that. And I look forward to hearing your thoughts on our work. Thank you very much once again. And with that note, I conclude my talk.